Hello, ladies and gentlemen. Welcome to our second part of the summer webinar series tackling with Idea StatiCa connection. Our today's topic are moment connections. My name's Jan Kubicek. I'm a product engineer in Idea StatiCa, and I will be your presenter today. For our webinars, we use a GoToWebinar platform. You are muted by default, but please feel free to ask questions whenever you have any. You can use the questions window, and my colleagues will answer your questions immediately through all the part. Well, so what's this summer webinar series all about? We will have 5 short webinars during all summer dedicated to the basics in work with Idea StatiCa connection application. So all the webinars will be free, and you will find the recordings on our website in the support center part or in our YouTube channel. So we can briefly show directly where you can find it. So if you type into your browser ideastatica.com, you will be on our home web page, and here in the tab Support Center, you will find many video materials, theoretical backgrounds, all necessary content you could use for your learning or solving your problem with application. And as I mentioned before, also on our YouTube channel, if you find Idea StatiCa, you can find our channel with tens, maybe hundreds of videos dedicated to webinars and technical solutions of specific problems. Okay, so back to our presentation. If you want to learn more about our application or to become a professional in steel structural connections, you could be interested in our Idea StatiCa campus, our online course, where you will find 12 lectures about how to use this application. It's about 30 hours of learning. It's interesting form, full of video and text materials, and also a live interaction with a tutor. You will earn your certificate verifying your abilities in steel structural connection design. In the previous part, you were shown by my colleague Adam Kozioszek how to start, how to run application, how to set correctly your license, and he gave you a comprehensive overview survey of the user interface in Idea StatiCa connection app. And what's today's topic? You probably already know. Today's topics is moment connections. Okay, so we're quite short on time. We have about 25 minutes to go through these six parts, between which the specifics of moment connection should be stated. We'll see how to model the moment connections effectively, how to apply load effects quickly, but more important, correctly, and how to work with equilibrium in loads. Then we'll show a short overview of connection stiffness analysis, and in the end we will give some advantages of pre-design feature. Okay, so what are the moment connection specifics? In the basics, we could say that besides a normal and shear force, the moment connection should transfer also bending moments between two structural members or from the structure to the foundation. So what are the typical uses for moment connections? Here we can see some steel frames, the main frames of some steel hull, and we have two types of moment connections here. Here we can see frame corner, a moment connection near the eave, and also the second type here in the ridge. As a second type of use is in multi-story structures like administrative structures or parking lots. Next type could be stiffening frames as an alternative for typical bracing field. So in the picture we can see some diagonal bracings here, but if we don't have an option to use them, we can use moment resisting stiffening frames instead. So how to model them effectively? We have several options in Idea StatiCa connection. The first one is choose a prepared option directly from connection wizard. In the third part of the window, we have prepared several options for moment connections. We'll see in the next part of presentation. Second option is to use prepared templates, or you can have your own user-defined templates. You can use a right-click option to create a connection you like. And the third and maybe the most progressive option is our new proposed function for specific types of typologies, specific types of connections prepared directly in the sets. Right, we can jump directly to the application to show all these options mentioned before. So if we run connection, we can create some new one. And in the first window, we can see it's connection wizard. We can see many sets of prepared connections. Here are some classes of connections, and because we are talking about moment connections, we will use the first option. The sets are adjusted according the design code used. So we can see that related to the region or location of our structure, the prepared sets can differ a little. So we just use this simple one, some hinged moment connection. And just by clicking on create project, we have almost finished connection model with some load already applied on it. So that was the first option, I think quite quick. We can clear the model of all the operations and we can show another option. So we mentioned templates. So if we want to select something like moment connection, yeah, we can see some hunched connection here. So we can try to apply it on our model. We have to select some bolt class and size. M16 looks correct. Okay, we have done almost the same as before. Now the third option, we have to clear it, and the right click option. So right click on the beam we want to connect, and we have to select to which another member we want to connect it. So we have several options here. We select the option we know already, and we have done almost the same as before by third option. Okay, and now the magic propose beta feature. So clear it again, and here you can see propose feature. Now we can select from types of connections, bolted, welded. So we will know if we want combine method or just one of these, and we can select our favorite one, click OK, and it should be very similar to the previous connection. Great. So these was the 4 options to model the moment connection correctly, and I think very quickly. Now we can jump back to our presentation. How to load the model quickly and correctly. Okay, again, we have several options, the same as with the modeling. So in the model window, we have to be in the load effects part, and we can simply edit the load effects manually, just rewrite the 0 values. This could be the fastest way, but if we have many load effects, many load cases, or many members, uh, it could be a space for some typos, for some errors. Then maybe some import option will be more appropriate. So we can select if we import the load effects from Excel sheet or from another connection file or connection project. So we will show simple way how to export all the loads applied in some model and create Excel file which we will use in another model. Okay, so here we have some prepared connection, quite simple one, 4 tubes welded together, connected to a simple column. We can see load effects here. These are all the same. It's a symmetrical connection. So we can export these loads into some Excel sheet. So I have prepared some load export here. I can save it there, overwrite, and I will find the Excel sheet in the folder, and I should find the same values in the Excel sheet as I have in my connection model. Great. In the next step, I can use these forces and import them into another model. So I can import another load effect. So by XLS import, I will have some table, and simply by using copy and paste method, I can select the range, click in the first, and by pasting it here, I can also choose if I want to replace existing loads or to add another load case. So I don't want to replace it now to see if somebody add it or not. So okay, and I can see the second load effect. It's the same as in the first one, so it should be correct. And the third option I have here is an import of load effects from some another connection project file. So I just try it. I have prepared some load import connection file. And here we should mention that if you have the same names of load effects in both projects, then they will be override overwritten. So if you want just add another load case, you should be aware of the names. So I have prepared some name I can recognize. So yes, I have another export import load case here, and everything worked correctly. Right. So back to our presentation. Now, equilibrium function. What's an equilibrium? Right, an equilibrium function. What's an equilibrium? It's probably one of the most important parts in modeling of connection in StatiCa. It's because we need to have equilibrium in every node, and if we import nodal forces from some global analysis model, it should be automatic. It should be automatic that the unbalanced forces in every node is equal to 0, but not always this is our case, because sometimes we just add load effects on one or two members, and all the others we will have calculated automatically, but the model doesn't have to calculate correctly, and the analysis wouldn't be correct. So as a simplification, I would recommend to have this option turn on in every project, and try to have always the unbalanced forces equal to 0. So we will show how to do it manually in our application. So I will use our model prepared before, and now I can see that I have forces on the members, but I can't see anything in the column. It's because this column is set as bearing member. By right-clicking on it, I can see it's set as bearing. Great. But if I turn on the load in equilibrium function, I will see that in my load effects, one row will be added. It's a row for a C member. If I turn it off, it disappears, and by turning on, it's there again. So now the application will calculate to me an unbalanced forces here in the bottom, and I can see that the Z value is not equal to 0, because no loads in the column. So I want to balance this force, and I will make it by changing the axial force value. So I have to add the exact value of the unbalanced force, and in the model view I will see a red arrow appearing at the end of the member, and now all the unbalanced forces are in 0. So I know now that my model is prepared correctly, and all the deformations, all the stresses calculated in the analysis will be correct and accurate. So that's what I want to have in all of my models, to be sure everything works fine. Great. Our next point is the overview of connection stiffness analysis. What we have this analysis for? We always assume some rigidity in the connection. When we calculate some global analysis model in applications like SAP 2000, SIA, or Global, we always connect members together by some hinges. they can be pinned or they can be rigid. These are the two most used options in global analysis models. But in real life, the most of the connections are semi-rigid, and we should know what's the rigidity, what's the rotational stiffness of such connection, and we can show how to calculate it very quickly. We have, although we have some manuals in our design codes, it could be quite time consuming, and we will see how to make it in a few seconds. So we can use a brand new model. Here we can create some new connection. I will try to use some not so typical for a moment connection. Okay, this cleat connection with T-shaped cross sections and angles could be appropriate. And I will try to calculate the stiffness of such connection. It seems a little bit like a rigid one because I have bolted not just the web but also the flanges of the beam. Okay, so for stiffness I have to turn it to the stiffness analysis and select the analyzed member. So now I can see that the C member is set as analyzed, but I want to analyze the B member. Okay, I have to check if I have correct values of load effects. So I need always some moment, some bending moment here, but probably always some shear force will be connected and have to be transferred. So it looks correct now, and I can calculate the stiffness. It should be a matter of a few seconds, and I will get some values of stiffness which I can use in my global analysis model. If I'm not in pinned or rigid mode, I will need something between. So it's not easy to find out what's the correct value which I can use. Okay, great. It looks successful. So now in rotational stiffness, I can see it's really semi-rigid according to this value in the class. And in the diagram, I can see the green line, which is my connection. The blue one is a limit for the pinned connection, and the yellow one is the limit for rigid. So I'm just in the middle. So I will need this SJ ini, so initial rotational stiffness for my global analysis model in global SEA or SAP or whatever I need to use. Great. So it was really a matter of maybe 1 minute of calculation. And pre-designed feature. Okay, so this is also quite new. This can save me a lot of time, precious time of calculating the connection on specific percentage of the resistance of the beam or some member. The setting for the pre-design looks like this. It's this window where in the pre-design part, in general, I can set a specific percentage of beam resistance, and it means that my connections will be automatically calculated and designed for this value of resistance. We can show it in practice. So again, we can jump directly into the connection application. Yeah, I have prepared some simple connection where by a template I have this simple connection, simple moment connection, and I want to be sure I can't resist 40% of the beam resistance in shear. So the settings is here. I want to jump into pre-design, and here I have the value I want to calculate. I can change it maybe to 50, save, and just by right-clicking on the operations, pre-design all, and the connections is automatically changed into the settings or a design where 50% of my shear resistance is exceeded. Great. And this could be all for today. So some brief conclusion, what we have done, what we have learned. So we showed the specifics of moment connections. We showed several ways how to model them in application, how to work with load effects and equilibrium, and a short overview of connection stiffness analysis, and in the end, the pre-design feature. So again, if you're interested into become an expert in steel connections, just check our Idea StatiCa campus on our website. You can register. A few of the lessons are free, and then you can decide if you're interested in go further or not. After our webinar, I will be glad to uh, get some short surveys, some short feedback from you in our questionnaire, and whole recording you can find it in the support center or on our YouTube channel. So please take a look there, and in the next part you will find shear connections in 2 weeks, and then we will see some complex connections. So thank you today for your attention. Once more, I will be glad for your feedback and some recommendations to our webinars or to our content on our website. So thank you once more and have a nice day. Bye.